Okay, so we're going to look at graphing quadratics. So this second equation here, y equals x squared, is like a standard quadratic or parabola, they'll call it. So what we're going to do is we're going to kind of supplement with Desmos here. So this is what a quadratic looks like, and there's actually some like major points along a quadratic. Can I get it to do it here? I used to be able to in the table. Hey, there we go. Made a table too. Oh man, I'm getting good with this. X squared. There you go. Got overlapping. So these are like some key points. -2. When x is -2, though it says x squared and it shows you the dots there, really what it's saying, I'll turn off the purple, is that the y value is 4. So when x is -1, the y value is 1. When x is 0, y value is 0. When x is 1, y value is 1. So you'll see it has like a repeating pattern. This is like a turning point, inflection point. And it kind of has very similar values, except when the x values are positive, it's got the same value as the negative x values. The y values are the same, I should say. So you see, you can almost like draw lines across it. Okay. So this is a really important one to know. You really need to know how to draw this one to start. Because if you don't know how to do this, then it's going to be really hard to translate because you have no concept of where to start. Okay. So make sure you can do this, and you can always extend it. Like 3 is technically 3 to the power of 2, so it's 9. The y value would be 9. If we had x value of 4, 4 to the power of 2, 16. So you just continue that pattern, right? And same goes here. -3 to the power of 2 is 9. -4 to the power of 2 is 16. So we just kind of go up like that, all right? So once we got that down, what we have is a whole bunch of different types of, these are considered translations, different ways you can translate a quadratic. So what I'm going to do is, can I move these? Got to move the whole thing. Okay, I'll draw it over here. Let's say we have y is equal to the a value here. So whatever that a value is, it deals with vertical. So I'm going to say up and down, stretches, and compression. So S and C I'm going to call it, okay? And those are probably the hardest ones to deal with. When it comes to drawing by hand, might be the very first step you want to take care of. It doesn't technically matter the order. It's just some are easier to do when it's in its original spot. We'll continue from there. So x, and then we have -h, and this has to do with horizontal translations. I'm going to say, I could say shifts, but I'm going to say t for translation. So this just means moving left and right. So you move the whole thing as a whole. There's no like warping of the shape. And then the k value is vertical once again. But this line is its translation, so it's moving up and down. So anything outside the brackets, your a value and your k value, they deal with vertical movement. So the k value is like moving the whole thing as it is. The a value is you keep like the vertex where it is, but everything else gets either compressed or stretched, okay? And then the h value is you leave the shape as it is, but you move it left and right. So we can do each of these kind of one at a time. If we take a look, first of all, we have to name them. So if you notice, I have 3 constants here, and they're in different spots. What value or what letter would the -3 represent, do you think? A, exactly. So here's our A value. So we know we're going to have a vertical stretch or compression. So if it's a value between 0 and 1, they call it a compression. And if it's a value greater than 1, they call it a stretch. Excuse me. And the negative values just flip the entire parabola. So if you remember the original one, it was kind of going upwards. You can show it on Desmos here. It's going upwards. But if we have, there's the purple one. If we say y is equal to negative x squared, it's just going the opposite way. It's like I'm holding a mirror right at that point. Exact same shape, just going downwards. That's all, okay? Actually, we'll keep it on for now. So great, we got that one. I'm going to go to the other value outside the brackets, right? So think about it. It's outside of that squared. What does the -1 represent? What letter?
K value.
K, great. So again, that's a vertical, this time translation. So you're actually moving the whole shape up or down. So let's take a look at Desmos again. Let's say it's that, I'm going to say y is equal to, and in this case, we're going to say x squared, but we're going to say down, what was the value I had, -1? -1. There you go. So you'll notice, let's turn off the black. black shape here. All that's happened is all the all the y values have been shifted down 1. See, that was 1, it's now 0. This was 0, it's now 1. This is, can I get it to go? I cannot get it to go. That would be to shift it down to 3, so I could actually turn this into a table of values, I believe. Yes, I can. There you go. You can see those same table of values. All we did is we shifted that one down, one value down. Okay, I'm going to rewrite the equation here so we know what we did in algebraic form. Okay, and we can turn that one off and turn that one off. And that's what they look like. Everything is just shifted down. The shape is the exact same. Okay, so that's important to remember. And then the value inside is 5. But I mean, by deduction, we know it deals with the letter H, and H is horizontal translations. The only thing is if it's positive, so I didn't specify this with the K value, well, I just kind of inferred. I said it was -1, so we just assumed negative means downwards. It's a common practice, like when we do temperature mathematics, something like that. Here, positive, well, positive on the X value is actually moving towards the right, but it's actually going to flip the sign. So if it says positive 5, it actually means you're moving the thing to the left 5. So I'll show you again with another equation. This one, I'll just write it as y is equal to bracket x plus 5 squared. And if you notice, same idea. Get all of our points. It's not giving me my points. Why did it give me points? Yeah, I don't know why it gives me that one up there. Oh yeah, give me these ones here as the important ones. Okay, whatever, no matter. I think it gave me those. Oh, that's why it's giving the same x values. You'll notice that this, turn this one off, it's just been shifted to the left. It's the exact same parabola, they've just moved it to the left 5 units. So you can take a look at its vertex, and its vertex there. All that's happened is it's moved to the left. The one we didn't talk about, and we kind of skipped over it. We talked about the negative movement where it flips, but we didn't talk about the stretch of 3. So I'm going to make one that has a stretch of 3 to it in Desmos. So let's say that would represent y is equal to 3x squared. And if you notice here, it's much thinner. Think of it like you took an elastic band and you pulled it upwards, it would get thinner. That's what we mean by a stretch. On compression, I'm going to show you. We're going to use a value here. I'm going to use fractional values are nice. Like if I say 1/3, it's kind of like the inverse of 3. It's technically a decimal value, but instead of writing it out, I'm just going to say 1 divided by 3 and then x squared. And if you notice, it's wider. This purple one's wider than the red. So the red's the original. The green is a vertical stretch, like you pull the elastic band upwards. And the purple is a vertical compression, like you're pushing the elastic band down and it starts to get wider, okay? We're going to focus on A being 3, okay? So, if we take a look, we have a whole bunch of different parabolas, but there was the negative flip, so that's one kind of movement. There's the vertical stretch for the number 3. There's the vertical movement of -1, and the horizontal movement of +5. That's 4 different things I had to do with the parabola. I did them one at a time, but we're going to try to piece the whole thing together as one movement, okay? So, let's turn off this green one. So, you'll notice there's a whole bunch of things here. I recommend the very first thing you want to do is usually stretch the parabola. So in order to do that, you can take all of these values and you can multiply them. You can multiply the y values by 3. So the x values are going to be the same. In fact, I can give you a small equation that you can plug things into. That helps you with translations. So, I think I may have shown you this before. The new x value, so I'm going to say x new is equal to, and y new is equal to. Your new y value is equal to a times the old y value plus k. And for x new, the x value is x old minus h. Yes. There's technically a k where we divide, but I think I might have shown you it, but you guys don't deal with that, so we're not going to build it in. So these two things are going to be really important. What they can do, instead of having to visualize everything like we were kind of doing on the graph, you can take really specific points and plug them into this little formula here, and it'll give you the new points to build it. Okay, so these ones will be important. Let's what we need to know here is the original equation, these 5 points. In order to use that little formula we built, we got to know these 5 points. So we have them, right? We have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So I know that table. Now if I want to translate my parabola, I can put it through that little equation. So, like we said, there's a whole bunch of translations here. I'm going to take the values that we have here. So like -3 is going to replace the a in this formula. -1 is going to replace the k. And +5 replaces the h. And you're going to notice that because it's a +5, it now becomes like -5 in the formula. So when I go to rewrite this little formula, we kind of have to build it every time. The new x value, I put a little n down there so we know it's the new one, is equal to the old x value. So those are the original values, and we'll talk about that. -5, and it's -5 because it was a plus here. Okay, so it kind of flopped, or it flips. And the new y value is equal to the -3 times the old y value, and -1 because the k value is 1, okay? So this formula is just specific to this equation. So let's talk about, let's go to our new page here. We'll add a page. Oh, it should not have been that hard. I should have just said plus. There we go. Remember we said that this table is important. So the x value and the y value. We know that there's an x value of -2. And the y value will be 1. Think of this as like a coordinate on the original parabola. -1, do you know what the y value is for -1? Well, there's a really quick way to solve it. Because the formula is y equals x squared, all you have to do is square your x values. So -1 times -1, and then that would give you your y value. 0 times 0 gives you the y value. 1 times 1 gives you the y value. 2 times 2 gives you the y value. Okay, so -1 times -1 is actually +1. Negative times a negative is positive. Zeros are zeros. This is 1 also. This is 4. So these are really important points. Let's take those formulas we built on the other page. So think of these as the old x values. Okay, the original ones. You could say O for original, O for old, whatever you want. We have to build a new table. Okay, and we need our new x values. Okay, and we need our new y values. These are the old y values. So we're going to take each of these points and put them through the formula, and whatever value we get, we're going to plug them into here as 5 new coordinates. Those 5 new coordinates will be really helpful for drawing our new parabola. Okay, so we look back to the other page, we had -5. Okay, great. So the new x value is equal to the old x value -5. That's one formula. And the new y value is equal to -3 times the old y value. What do we say? -1. Great. -1. So are you okay with how we built these formulas? Okay. So great. The very first thing we're going to do is I'm going to take this coordinate. Right? So -2, that's going to go into this x. 4, that's going to go into this y here. Then we equate, and whatever values we get, we plug in as the new coordinates. Okay, so let's attempt this here. The new x is equal to, the old x was -2, so -2 minus 5. I use a calculator, very quickly tells me it's -7. Great, okay, so this one is -7. And then the new y value is equal to -3 times the old y value was 4. Okay, so I plug that in, -1. Well, I can use a calculator. I'm going to quickly do this. -3 times 4 is -12. -12 minus 1 is -13. So here is one of the coordinates. Okay? I can repeat that for all 5 of these. Continuously using these 2 formulas every single time. I just plug new things in. Okay? I'll quickly do them. No, you know what? I want to draw them. I want you to see what we're doing here. So same concept then. X new is equal to... I will write x old. I want to be very clear what I'm doing. I don't want to make it too visual. Sorry, I want to make sure there's visuals. Xn equals -3y old minus 1. Great. Next x value is -1. So the new x value is equal to -1 minus 5. It's going to be -6. So I write it in, okay? And if this is too fast for you, you would just use a calculator when you're able to do it, okay? Xy new is equal to -3. The old one was 1. So negative 3 times 1, negative 3 minus 1, negative 4. Here's my x value, okay? Same concept again. X new equals 0 minus 5 gives me negative 5. You'll start to see I'm getting a pattern. Negative 7, negative 6, negative 5. Probably going to be negative 4 and negative 3, right? But we'll do them all out. Negative 3, the old y value is 0. Minus 1, negative 3 times 0, 0. Minus 1 is negative 1. The y values, I don't quite got my pattern yet.
Is that because this is the difference of 1?
Yeah, that's why you're kind of seeing that pattern. And essentially what's happened is all these x values have shifted 5 to the left, right? Negative 2 to negative 7. That went over 5, went over 5, right? And that's what we talked about. It's a horizontal shift. Harder to see when it's values of a number, easier when it's in a graph, okay? We'll do each one. X new is equal to the old x was 1 minus 5. It's going to be negative 4. Great, that worked great with our pattern. The new y is equal to negative 3 times the old y was positive 1. Oh, this was negative 1, wasn't it? Yes, it was. Oh, I made a mistake here. Negative 3 times negative 1 should have been positive 3. I made the same mistake here. Ooh, I forgot to include... Oh, no, they were never negatives. Ooh, thank goodness. Thought I made mistakes. Right, those values are the same. We're actually going to get the same value because we're starting to use those numbers again. This will become negative 3, negative 4. Right? And if you remember, these two end up being the same as that. So this one's going to be negative 3, and according to this should be negative 13. Great, I have my points. I can, on a graph, give myself a rough sketch here. We'll say this is negative 1, negative 2, negative 4, negative 5. Okay, so, oh shoot, I got to go to negative 7. There's negative 7. I got lots of stuff over here. And it goes all the way down to negative 13. So I really got to extend this graph a bit. Let's go down by, we're going to do estimating, and we'll go really accurate on that graph, okay? So at negative 7, we should be at negative 13. I'm going to say that's about here. Negative 6, we should be at negative 4. It's about there. Negative 5, we should be at negative 1. Probably about there. And then the y values are the same again for 4 and 3. And we do a rough sketch. There we go. Here's my parabola. That's my general sketch of it, okay? And all I did was take the coordinates from that table.
Right.
But let's actually see what that looks like here. We can write this parabola out. Y equals negative 3 bracket x plus 5, correct? Yeah. Squared minus 1. And if we take a look, I'm going to turn it into a table like I did before. And I want coordinates negative 7, we said. We want negative 6. I just want to prove that we were right when we did it, okay? Negative 6. Negative 5. Negative 4. And negative 3. If you remember, those are the exact values we had. I mean, the graph looks a little different because of how they've stretched I stretched the page. It looks thin here. On mine, it looks really wide. If you remember, that's just because of the scale of my graph. My graph is scaled pretty funny. But those are the exact same values, okay? So, to visually show you what happened, this parabola flipped over. That was the negative. It got thinner by a factor of 3. It shifted to the left 5, and it went down 1. Visually, sometimes difficult to put all those things together, but that little formula on the other page can be really, really helpful for putting it all together, okay?